In the past podcast, I've talked about current and potential, and in this podcast, I want to talk about the rules that govern current and potential. Specifically, I want to define Kirchhoff's rules and kind of set up a little bit about what they mean. So the important point to remember about Kirchhoff's rules is that this is the foundation of all electronics, and they're true in every circuit at every instant of time. This is like Newton's laws in mechanics. They're always true at every instant of time. This is how the world works, and you don't get to argue that fact, right? We've done experiments, and this is how it goes. And so this quarter, we'll look at a lot of different circuits, and there'll be a lot of different circuit elements, and each one of those circuit elements will vary. They'll differ, their behavior will change, but at every instant of time, Kirchhoff's rules will be true. And so quickly, Kirchhoff's loop rule, which is basically conservation of energy, says that sum of the changes in potential around any closed loop sums to zero. The loop rule is written as follows. Kirchhoff's junction rule, which is essentially conservation of charge, says the sum of the currents flowing into a junction is equal to the amount of the current flowing out of the junction, and it's written in the following two ways, either as the sum of the currents into a node is equal to zero, or the sum of the currents into a node is equal to the sum of the currents out of a node. So let's see a little bit more about what this means. So here's Kirchhoff's loop rule. Again, we said this is essentially conservation of energy. And so if you thought about going around a circuit, what it essentially says, if you go around the circuit and come back to the same spot, that spot's going to have the same potential. That sort of makes sense. That's the same thing as the analogy is going up a hill, right? If you start at some point on a hill and you go up the hill and down the hill and come back to the same spot, you're going to be at the same height. So essentially, that's all Kirchhoff's loop rule is saying. But it also means that the change between any 2 points, the change in potential is going to be the same independent of the path you get there. So in circuits you can have one path between 2 points, 2 paths, 3 paths, whatever, but the change in potential between those points is always going to be the same. So let's look at the junction rule. And so the junction rule, we said, is essentially the currents going in equal to the currents going out, right? We can't create charge, we don't destroy charge. What goes in comes out. And so a useful analogy is to think of water in a hose. And so, but you want to have the right analogy. So you want to think of a hose full of water. If you imagine putting a little more water into the hose, a little water will come out the other end, right? The same amount. So that's essentially what the junction rule is saying. And that's the same thing in a wire. There's a certain amount of charge in the wire. If we put a little bit of charge on one side, that same amount of charge will come out on the other side. That ends this podcast.